So we're on 10.3b, working with array lengths. So JavaScript array automatically expands in length as more items are added. To determine an array's current size, apply the following length property. Where array is the name of the array and the value returned by the length property is equal to or one or more than the highest index number, because again, indexes start at 0. So if the highest number in the index is 11, then the value returned is 12. JavaScript allows for the creation of sparse arrays in which, let me go back up a little bit and see if I still have the other window open. Yeah. And it went away, didn't it? Oh, okay, still there, good. So month, remember this, what we did on the last one, month of the year by numbers. And then let's go ahead and add a description on this. Months of the year by array index values. Okay. So the highest index is 11, but it actually is number 12 because it starts with a 0. So JavaScript allows for the creation of sparse arrays in which some array values are undefined. As a result, the length value is not always the same as the number of array values. So, for example, the following commands create a sparse array in which only the first and last items have defined values. So we have a variable named x. It's a new array. We're not specifying anything here. We got the x, the variable x of the first value, remember, starts with 0, is Lewis, and the 99th value is whatever, 80517. It's a string. It says the value of the length property for the array is 100, even though it only contains 2 values. That's because sparse arrays occur frequently in database applications involving customer records where items such as mobile phone numbers or postal codes have been entered for every person. So to determine the size of an array, you can use the property of array.length. We don't have an example there. Where array is the number of the array is the name of the array and the length is 1 more than the highest index value. To add an item to the end of an array, run the command. You have the array, the index value, the index number equals value. Where I is the index value higher than the highest index currently in the array. If you don't know the highest index number, use the property array.length in place of I. To remove items from an array, you can run the command where the array.length is value, where the value is smaller than the highest index currently in the array. Note you cannot reduce the value of the length property without removing items from the end of your array. For example, the following command could reduce the month name array to the first 3 months. Okay, so just be aware of that. If we're going to reduce it from our number of months from 12 to 3, it's only going to have January, February, March, yeah. Increasing the value of the length property adds more items to an array, but the items have no values that are defined until they are defined. So many database applications need to store data in a rectangular format known as a matrix, in which the fields are arranged by a rectangular grid. The following is an example of a matrix. So there's 3 rows and 4 columns. The rows and columns in a matrix form the basis for the indices. I think that's how you say that. For example, the value 18 from the matrix is referring to the index pair 2 and 3. So 18 is right here. And so index pair 2 and 3. I think it starts with X, Y. So 0, 2, 3. Starts with Y, I believe. Okay. So it's a second row, third column. Yeah. So second row and third column. Although matrices in the plural version of however you say it are commonly used in databases where each row might represent an individual and each column a characteristic of that individual. JavaScript does not support matrices. However, you can mimic the behavior of matrices in JavaScript by nesting one array within another in the structure called a multi-dimensional array. For example, the following code creates the array M-array, which is the name of the variable of an array that contains a collection of nested arrays. So we have it, we're saying it's an array by using these square brackets right here, and then we're nesting it. Note the values of this array match the values of the matrix shown above, that, and that. In this case, the first nested row matches the first row of the matrix, the second matches the second row, and the third matches the third row. The values of the nested arrays are matched with each of the 4 columns. So values with a multidimensional array are referenced by the expression array xy. So where x contains the index of the outer array, the row, and the y contains the index of the nested array, the column. So it's the row first and then the column. So returns the value of 18 for the matrix second row and third column. Remember that indices start with 0, not 1. The number of rows, okay, right here is what they were talking about. So it starts with 0. So 1 is actually representative of the number 2, and 2 is actually representative of the number 3. So M-array, which is the variable of the array that were created here. 1 is the x value, which x is across, or the row rather, and 1, sorry, okay. I'm getting myself confused here. So x is this, and y is this. Let me read this again. So for the second row, so we're looking at rows. I'm getting myself confused. We're looking at the second row, and then we're looking at the third column. Yeah. Okay, which is number 18. So the number of columns can be determined by retrieving the length property for the first row of the table. The number of columns can be determined by retrieving the length property. Okay, so the first row is going to help us determine how many columns there are. So we're going to look at the M-array, the variable name, and we're going to look at the first index, or the index value of 1, which is this row right here. And we're going to look at the length, which is 4. No, this approach presumes that every row has the same number of columns. You can continue to nest arrays in this fashion. Okay. That's all for 10B. Let's keep going on to, I'm just going to separate them by the letters, but let's just keep going on. 10.3c, reversing an array. Arrays are associated with a collection of methods that allow you to change their content, orders, and size. You can also use these methods to combine different arrays into a single array and convert arrays into text strings. Although you will not need to use the methods in the calendar app, you will examine them for future projects. So by default, items are placed in an array either in the order in which they are defined or explicitly by index number. So JavaScript supports 2 methods for changing the order of these items, reverse and sort. The reverse method, as the name suggests, reverses the order of items in an array. making the last items first and the first items last. The following set of the commands, the reverse method, is used to change the order of the values. I'll pause this for a second. Okay, so let's open up a console log and a web page and just kind of play with this a little bit so you can have some practice. I'm not going to do that one. We're going to go ahead and do this. So I got another browser tab open. Hit Control-Shift-I, or you can right-click and hit Inspect. Whatever you need to do to open up your developer tools and go to Console. So let's just work on creating a variable of an array. We're going to create an array with a variable name of weekday, and we're going to give it those days of the week. So we do that, type in var weekday. You see, we already did it earlier. Sun, Mon, Tues, Wed, Thurs, Ga, Sat. Okay. So this is what you should have typed up. And if you hit enter, it might say undefined. And then if you call the variable, what you do by typing in the variable name, weekday, you should see it come up. So we created the variable name weekday, and we put in those array parameters. And then we're just going to call up weekday by just simply typing in weekday. And you can see that it gives us some information. It gives us our information of Sunday through Saturday. If we hit that arrow, it talks about Sunday having an index value of 0, Mondays 1, Tuesday 2, Wednesday 3, Thursday 4, 5 is Friday, and Saturday is 6, but it has a length of 7 because there are 7 numbers, even though it starts at 0, it only goes up to 6. So I don't know if this will work. I think it should, but I've been known to be wrong a lot. Okay, so if we do a weekday length, if we're looking to see how many arguments we have in our, or how many indexes we have in our variable named weekday, we can type in the word length using the variable weekday, type in the word length, and it'll give us 7. What if we want to create another variable named, let's do months of year. Let's not have so much time. Months of autumn semester. So that would be August, September, October, November, December. Okay. And we hit enter, and then we call that variable months of autumn semester. It'll say our months that we already read in there. I talked earlier about how you can mix and match the different types of values. So let's say, oh shoot, let's do this again. Months. I can't reuse the same variable. I don't want to reuse the same variable name. Oh no, I'm horrible at thinking of examples on the spot. This is why I prep ahead of time. Months of spring. Okay, let's do that. So it starts with January. So we're going to go ahead and put January. And then I'm going to put 2 for February, just because. And then we're going to say 3. It's in a string because it's got quotes in it, just because. March, April, and then May. I'm not putting that in quotes, so what's it going to do? I don't know. So make sure you got square brackets. It is not defined because I have a problem with May. May is not an integer, and I don't have quotes around it. So I can hit the up arrow and I'll get back to those lines, that last line, and just go ahead and put quotes around it. Okay. So you see that it represents whenever, yeah, you can see what you see there. You can call it months of spring semester, and it'll give you the information. If you want to see how many how many values are in there, you can call with the variable and then type in the word length, and so it'll tell you there's 5. So that's some ways you can play with array values. But what we're talking about here is reversing it. So I'm going to hit the up arrow instead of typing in stuff again. You can hit the up arrow to find, the various lines that you've already written in there, which is right there. Yeah. That's the one I want, but I want to reverse it, like for the assignment right here. So I had this ending with a semicolon, like this is. And then if you hit enter, it'll mess you up a little bit, I think. Weekday.reverse. It may work, I don't know. It did. Okay. So when you hit reverse, when you do the weekday dot reverse, it gives you the days of the week in reverse. Just like how we did the length earlier, it gives us the number 7. When we do reverse, it gives us our information that we're looking for, which is the days of the week in reverse. We can do the same thing with months of autumn semester months of autumn semester. Yeah, that's right. Reverse, and it gives us our months in reverse. Okay. Is that on this page? Yeah, okay. 10.3D, sorting an array. Okay, the sort method rearranges array items in alphabetical order. This can cause unexpected results if you apply the sort method to data values that are not usually sorted alphabetically. So applying the sort method to numeric values will sort the values in order of the leading digits rather than the numerical values. So just be aware of that. So I would put a note on here. Make sure I'm telling you right. Yeah. You actually use this as an example. So if you have a variable of 3, 45, 1, 2, 3, 4, and 24, obviously 3 is before, when you're talking numerical values, 3 is 3, and then there's 24, then there's 45, and then 12, 34. But it's looking at the leading digits, which on this is 1, on this is 2, on this is 3, on this is 4. So that's the order it looks for. So let's go ahead and hit clear. I'm going back to our console, hit clear, and parentheses, and I'll clear that out. So let's mimic this. Var x equals, use an array by with the brackets, 3, 45, 1, 2, 3, 4, 24, or 24. Semicolon, I'm saying it's undefined, that's fine. X dot sort. Okay, so it sorts them, but it puts them, again, like the book was saying, it by leading value, which is not correct. 3 is less than all those other numbers. To correctly sort numeric data, you must create a compare function that compares the values of 2 adjacent array items. So the general form of a compare function is function fname AB, return a negative, positive, or 0 value. This is stuff that I hate. Where fname is the value is the name of the value function, and A and B are parameters that represent a pair of array values. So we got A is A, return A positive, return A negative, positive, or zero value. Is that what that means? Okay, let me back up a little bit. F name is the name of the compare function. And A and B are parameters. A and B are parameters that represent a pair of array values. The function then returns a negative, positive, or zero value based on the comparison of those values. Okay, I got ahead of myself earlier. Sorry. This is why I don't like things like A and B, because I thought, yeah. So, okay. The function then returns a negative, positive, or zero value based on the comparison of those values. If a negative value is returned, then A is placed before B in the array. If a positive value is returned, then B is placed before A. And finally, if a zero value is returned, A and B retain their original positions. The compare function is applied to every pair of values in the array to ensure that they are sorted in proper order. Okay, let's try this out here. So I'm going to go back to my console and hit clear. I'm not using A and B. Let's do ascending. Let's do 4 and 7. What did I do? Oh, you can't do that in there. Oh, shoot. I did something. What did I do? Unexpected number. Function ascending. Let's try this again. I might just ascending A, B. Okay. Actually, I'm gonna refresh this page. I'm gonna do something different. I still don't like the AB. Refresh. Let's open up a new tab. Okay, try this again. Function ascending. Let's go to X and Y. Return X minus Y. Okay. Whereas to sort numbers in a descending order, you could return the following function, which subtracts A from B rather than B from A. Descending X, Y. Return B minus A. Okay, so we have a function name right here, and we're naming the function. We're naming this function ascending. So if something is ascending, we're taking our two arguments of X and Y, and we are going to, return X minus Y. We have a function name of descending, which I can't spell right. Descending. We're telling what the function is going to do is take our parameters of our arguments of X and Y, and we're going to do B minus Y. Other compare functions are possible to deal with a variety of sorting roles, but these two are the simplest for sorting arrays of numeric values. So the to compare function is applied to the sort method as follows. This might have been a carryover from this one. Oh, okay, this is what I was looking for. Okay. So we got a var, we declared var x equals 345, 1, 2, 3, 4, 24. And we're saying we want it to sort. And this is what it comes up. The leading digits, 1, 2, 1, 2, 3, and 4, right? But if we wanted to sort by ascending, we would say x dot sort, and it's not sortie, x dot sort, and we're going to call the function name of ascending. Okay, and it comes up as correct. 3, 24, 45, 1, 2, 3, 4. So what it's doing is x minus y. Return x minus y. It's right. I'm just having a difficult time explaining why it's right. So if we did x dot sort descending, and I didn't spell it right. X dot sort descending. I spell it right this time? No. How did I spell it? I still misspelled it, didn't I? Okay. X dot sort. Let's do it how I have it spelled right here, because I can't spell it evidently. DESCED. There it is. Now what? B is not defined. Oh, I just screwed that all up, didn't I? See how I have X and Y? Because I didn't want to use A and B. Well, now it's saying that B and A is not defined because I didn't define it. So let's just try to do that function descending all over again. Function descending, and see if I can spell it right this time. Descending. That looks right. X, Y, return y minus x, closing curly. Okay. X dot sort descending, the correct version. There we go. Right? Yeah, that's right. Okay. So, what's interesting, I think me doing that and mucking that all up, that helped me have a better grasp of how to explain this. So, we're looking at our parameter values on this ascending one, x, y. So whenever we're looking on this variable x, 3 is going to compare two values at one time. 3 is, in this example, x, and 45 is y. And it's going to do, I think bubble sort is probably the correct term. It's going to look at those two, and it's going to say if ascending, if it's 3 and y, return, if we're going to return x as 3 and y is 45. And you can see between those two characters right there, that's correct order. So 3 is first, And then it's going to look at the next X and Y combo. It's going to look at 45 as X and 1, 2, 3, 4 as Y. And looking at that right there, that is the correct order. Okay. And then we start looking here. 1, 2, 3, 4. 1, 2, 3, 4 is X and 24 is Y. You start looking here, and that's not correct, right? So we tell it to, it's 24 has got to go before 1, 2, 3, 4 because that's how it needs to be. I think this might be better to find in a video. I think that's what I'm going to do. Okay, so make a note here. I'm going to actually pause this. Okay. Okay, I'm back. I want to show you this video. I think it explains it better than what I could probably kind of muck it up. It's CS50, which if you remember, if you were in class Thursday, is one of the MOOCs that I like. And I like the way he explained things.
Roll of a certain number right now. So I'm going to go ahead and give each of you a number in sorted order initially, but that would be too easy. So if you don't mind, let's go ahead and arrange yourselves behind these music stands in the same order that you see on the screen. So on the left end here near me should be the number 4, then 2, then 6, then 8, good job, then 1, then 3, then 7, then 5. All right, so now, and you can put the numbers on the music stand there, but just move them with you as you go. So now the question is, here is a seemingly random list, just some order I came up with somewhat arbitrarily, and I want now to sort my list. How do I go about doing it? What would you propose? The goal is to get from 1 to 8. What are our possible approaches here? Oh, you want to? Sure, okay. We'll just do it over here. Okay. Okay, good. So let's go ahead and do that. So let's see, and what's your, let's for those tuning in at home, what's your name again? Allison and Alex, Adam, Brandon, Joseph, Vicky, Arpin, Derek. Okay. So now, because that all just was too much to absorb, number 1 is now the first smallest element according to the proposed algorithm. So what are we going to do exactly with number 1? Okay, good. So hop back if you would. You guys are going to shift 3 places this way, and we're going to insert number 1 at the beginning of the list. All right, so what's the next step, just to be clear? Good. Good. So we find the next smallest element, which happens to be 2. We insert him at the beginning of the list here, and now we move on to the number 3 problem. Excellent. So pop back, shift, and insert. Good. 4, we got lucky, so we don't have to do any extra work here, so that's a freebie. Now we look for 5. Oh, there's 5 at the end. Good. And now 6, we got lucky. 7 and 8, we need to fix that. Okay, good. So I like this. It felt pretty fast, though to be fair, the list is pretty short. But we were doing kind of a lot of work, right? In fact, that was perfect, the fact that number 1 was all the way over here, because we shifted 3 humans. And can you guys reset for just a moment? Let me propose an alternative approach. So if number 1 is in the middle here, and really belongs all the way there on the left, we went to great lengths, it seems, to shift all of these volunteers to the left, which is a lot of steps, because at the end of the day, let's assume for today's purposes that a computer can only do one thing at once. So even though all of you humans moved pretty quickly, that was really like one of you moved, then the next of you moved, then the next of you moved, then the next. So that was like 4 total steps just to put number 1 on the end there. Let me propose this. 1, can you pop out again? Now this list, so far as I'm concerned as the computer, is perfectly random from the get-go. So why do I even care that you guys move? I haven't even looked at the rest of these elements yet or done anything with them. Why don't I just evict number 4, where number 1 belongs, if you want to go over here? And if the list is already randomly sorted in the beginning, well, then fine, 4 are going to go over here. So I've made the problem no worse, but I have made it slightly better by putting 1 on the end. Now I'm going to go ahead and select the next smallest element again. 2, I got lucky. Now I'm going to look for the next smallest element. 3, indeed, is the smallest. So let me do the same thing. 3, if you could pop back. 6, you're out of there. And notice that we're doing less work. Now the humans are moving a little farther physically, but that's fine. The computer can just move values around in memory pretty fast, but I've moved fewer of you. So this is a slight optimization. It turns out this isn't fundamentally better, as we'll see, but it's this instinct that you should appreciate of trying to do the least amount of work possible, because otherwise it's going to add up. Let's try another one. Well, let me clarify one thing then. So what am I doing on each iteration of this algorithm? As you suggested, I'm selecting the smallest element. But the only catch is, if I'm now looking for the next smallest element, that's going to be 4. But I'm only sure that it's 4 once I get to the end and realize, yep, that was the smallest element, and then I act. So once we fix that problem, if you guys want to switch, I start again over here, and I have to find the next smallest element. And let's see, 8 is pretty big, 6 is smaller, good, 7 not smaller. But only once I get to the end do I realize, oh, here's the smallest. So in short, to find the smallest element, as you proposed again and again, I have to keep going through the whole list, because it might be all the way at the end. We humans have the advantage of just kind of looking, sort of taking a step back and saying, okay, this is obviously unsorted, I know where everything is. A computer can only look at one number at a time, one element of an array at a time. So let's try a fundamentally different approach. If you guys could reset to your original 8 locations, let me propose that we just looked at an algorithm we'll call selection sort. Selection sort insofar as you iteratively, again and again, select the next smallest element. Let's now do an approach that we'll call bubble sort, which has sort of the visual effect of numbers bubbling up over time as follows. You know what? I'm just going to look not at the whole list, because it felt like that was creating a lot of work for me. I'm going to look at 2 numbers at a time, 4 and 2. Are these in order or out of order? Obviously. So they're out of order. So you know what? I don't care about the rest of the problem. Let me just swap you 2. All right. Now let me take one step, look at 4 and 6. In order or out of order? In order. So I'm going to leave it be. 6 and 8, in order. 8 and 1, not in order. So let me swap that again. 8 and 3, out of order. Let me swap that again. 8 and 7, out of order. Let me swap that again. 8 and 5, out of order. Let me swap that again. And now what has happened? Is the list sorted? Because I fixed all the pairwise mistakes. So obviously not, but is it better, the list? Why is it better, Derek? Yeah, exactly. 8 bubbled all the way up to the top, if you will. So now he is effectively done. And frankly, every other number that's smaller bubbled one step closer to its position. So we've taken one big pass through this to solve at least one of the problems. And now maximally 7 problems remain. So let me go back to the end here. And let me look at pairwise. 2 and 4, you're good. 4 and 6, you're good. 6 and 1, let's fix that. 6 and 3, let's fix that. 6 and 7, we're good. 7 and 5, let's fix that. And now I can ignore number 8 because I know the end of my list is sorted. So now I've improved it slightly. 7 has bubbled up to where he needs to be. I just have 6 problems left to solve at most. So now I look again. 2 and 4, you're good. Oh, 1 and 4, let's swap that. And notice 1 is moving closer to the left of the list. 4 and 3, let's swap. 4 and 6, you're good. 6 and 5, you're not. But now I fixed 6, and I can stop here, leaving me with just 5 potential problems. And then you can see where this is going. 2 and 1, let's swap. 2 and 3, you're good. 3 and 4, you're good. We already solved these problems, so let me go back. And now 1 and 2, you're good. 2 and 3, you're good. 3 and 4, 4 and 5, 5 and 6, 6 and 7, 7 and 8. What do I know now as the computer? It's sorted. Why? Everything is in order, but what does that mean? We humans can see that, but the computer can only look at individual values at a time. It can't take a step back and say, yep, sorted. Good. At a lower level implementation detail, I did no swaps. There were no 2 numbers that were out of order, so it would just be foolish of me and wasteful for me to bother doing another pass, because assuming the numbers are not changing on their own, I'm just going to do the same thing again and again otherwise, so I can just stop. And indeed, the bubble sort allows us to stop like this. Let's do one last approach, if you could. Let me toss the starting points on the board again. Let's reset one last time to this. And let me draw inspiration actually from the approach you took with the blue books, which was a little different from how we began, which was...
Okay, I'm going to stop there. So that explains a lot better with the visual aids than what I was trying to explain without the visual aids. Get my screen situated. There we go. Okay. So it talks about doing a random shuffle. For some applications, you will want to randomly rearrange the contents of an array. For example, you might be writing a program to simulate a randomly shuffled deck. You can shuffle an array with the same sort method you use to place the array in a defined order. However, to place the items in a random order, you use a compare function that randomly returns a positive, negative, or zero value. So in this function, the function name rand order, sorry, return 0.5 minus math random. So let's see. The following code demonstrates how the compare function could be used to randomly shuffle an array of poker cards. So we have a variable named poker deck. It's a new array that's telling we got 52. Poker deck is 0 equals 2 of clubs. Poker deck 1 equals 3 of clubs, and so on and so forth. Poker deck of 51 equals ace of spades. So we're going to do a random order, and then after running this command, the contents of the poker deck array will be placed in a random order. So let's go in here. I'm in W3 schools. Maybe I am. Okay. Let's see. Let's go out this tab. Make this bigger. So what was I doing? Random order. Let's see, it might be under math or random. Let's try this one. Okay. So we got JavaScript, math, that's the heading. We got a paragraph, we got a demo, we got a script. So document get element by ID, demo, math random. So it doesn't look like it gave us any kind of parameters, just being it's going to be a random number between 0 and 1. So that's pretty much it. You can do a math random if you give it parameters, which this did not. Let's see if there's another one. Okay, we got a math. Returns a random integer between 0 and 9. So it's just another way that you can do a math random. You get a demo.enter HTML. Yeah, that's what I should do. But it's basically just like a random, like, when you shuffle cards, as the example said. I'm not going to mimic that. Putting all the other ones in there. Let's see how it would work if we just kind of did like a simplified version. Let's see. So I'm going to open up this. So what I'm in is in a console again, maybe. Maybe. It's being very slow. Okay. So we're going to declare a function called function rand order. What it's going to do is return 0.5 minus the math dot random method. Okay. So now we're going to declare a variable called poker deck. Var poker deck equals, or we're going to say it's a new array of 52. Actually, I'm not going to do 52. I'm only going to do 3 because I'm not going to, yeah. That's we're saying it's going to have 50, or it's going to have 3 index values. So poker deck index value of 0 equals 2 of clubs. poker deck index value of 1 equals 3 of clubs. Poker deck index value of 51 equals, try that again, equals ace of spades. Did I do that right? Yeah, okay. Oh, what did I do? Ace of spades. Poker, oh, I got a curly Q instead of square bracket. Try poker deck 51 equals ace of spades. Try this one. Okay, there we go. So we got those 3 right there because, again, I'm not going to do all 52. And the reason this is 51, it's the final one, but they were saying it's 52 index values is because it starts with a 0. So we're going to do poker deck sort, poker deck dot sort, and we're going to call our function that we called earlier of rand, or we named earlier rand order. We'll be placed in a random order. Okay, so the contents are placed in a random order. And it does show it's empty of 49. Okay, so it's got 52 because okay, back up. Okay, 0, 1. Remember how we said earlier that if it comes up to a value of 1, then there's like a lot missing in between, like one from 1 to 51. Ignore this one because that's an error. It went from 1 to 51 and it's got empty of 49 because we didn't declare anything, for the other 49. But it puts them in a random order: 3 of clubs, ace of spades, 2 of clubs, which is in a random order. Let's try this again. So hit up arrow and it re-randed them. There's only so many randoms that it can do, evidently. Yeah. So let's see what would happen if, no, let's just leave it alone like that. Not diving into that anymore. But yeah. Okay, moving on. So extracting and inserting array items. In some scripts, you might want to extract a section of an array known as a subarray. One way to create a subarray is with the following slice method. So you got array.slice start stop, where start is the index value of the array item at which a slicing starts, and stop is the index value which a slicing ends. Note that the stop index value is not included in the subarray, and the stop value is optional. So just make sure that you see that it's not included. It's where it ends. It's optional, but it is not included. If it is omitted, the array is sliced to its end. The original contents of the array are unaffected after slicing, but the extracted items can be stored in another array. For example, the following command slices the month name array, extracting only 3 summer months of June, July, August, and storing them in summer months. So remember that the array starts with a value of 0, so the 6 months of the year is actually a value of 5. Okay. Let's see where that takes us on this. So I'm going to clear this out. Yeah, go ahead and clear this out. Let's go ahead and create a variable name of summer months. No, let's go ahead and, no, let's create a variable of months of year. Jan, Feb, March, April, May, June, July, August. Sorry, I blanked for a second. Sept, Oct, Nov, Dec. Oh. So months of the year, if we call upon it, it'll come up. We got 12 months. Say we only want to look for the summer months. So let's see how this works. Summer months equals months of year. We didn't name it the same as that. So we're looking at the months of the year dot slice. So we want the summer months of, this is where the number can get kind of confusing. We're wanting the months in the natural language of starting with 1 equals January. We're looking for June, July, August, right? June, July, August. So in the months of the year, we're looking for June, July, August. So that's May, June, that's 6, 7, 8. Okay. But 6, 7, 8. But in the regards to the index values, 6 is 5, 7 is 6, and 8 is 7. Okay. So we're wanting to do the start and the stop. So it was 6 equals 5. So we're wanting to do 5, comma, which is the start, and then the end, and it tells us right there. End is 7 to August, right? June, July, August. 6, June, July, August. So 8 is the end, but it says also the stop index value is not included. So hold up, let me get myself confused. So 6 is 5, 7 is 6, 8 is 7. Okay, so we're going to put an index value of 8, but it's not included. And it comes up June, July, August. So there's slice and then there's splice. So we can splice it as well. Which in the general purpose method for removing and inserting array items, where start is the starting index in the array and size is the number of the array items to remove after the start index. The values is an optional comment separated list of values to insert into the array. If no values are specified, the splice method simply removes items from the array. So the following statement employs the splice method, removing the method to remove summer months from the month name array. So let's go over this again. So we have a start, where start is the starting index in the array. So on this, index is 5, and that equates to 6, right? Which is June. So start is the start index of the array. Size is the number of array items. So we have 3 items. So starting at index 5, and there's 1, 2, 3 items. Which, in regards to traditional values of starting with 1, 5 is 6, 6 is 7, 7 is 8. So 5 is June, 6 is July, 7 is August. If no, and values is an optional comma separated list of values to insert into the array. So in this example, there's no values. We just have the start and we have the size. So it's telling us to start at index 5 and to take out 1, 2, 3 size, 3 of them, which again is the 5 is June, 6 is July, 7 is August. So let's do that. So we got summer months equals month. Oh, I named mine different. My variable's different because I named it months of year instead of month name. Months of year dot splice. Our starting value is 5, and we're telling it to move it out 3 index values. Take out 3 of them. And it's going to do June, July, August, which are the 3 values starting with index of 5. And then if we do look up our months of year again, you'll notice that June, July, and August are gone. It goes from April, May, missing out June, July, August, and goes straight into September. However, to insert new abbreviations of month names into the month name array, you can add the following splice method, which places the value of June, July, and August into the array with the 5th index number. Okay, so if we need to put them back in, sorry, that's not what I wanted to do. We can do month name, where for me it's months of the year. Months of year. Sorry. Okay, 5 because that's the index value that we're going to start with. 3 is because that's how many indices, how many that we're going to put in there. And then we are going to put in what we want it to be. So say for whatever reason, instead of the names of the month, we want it to be the values. We want it to be represented something like this. Okay, just so you can see the difference between what we're going to do. Oh, I have an error somewhere, and months of year is not a function. What are you talking about? Oh, shoot. Okay. Forgot the word splice. So it's months of year dot splice. Okay. I still did something wrong. What did I do wrong? Oh, well, it's not quite what I wanted to do. What it did, it went to what was the 5th one now, which was 1, 0, 1, 2, 3, 4, 5 in September, October, November, and it took out September, October, November. But it put in what I was trying to put in, so I did something wrong. With the month name array, you can. Let's see. Months of year. Let's try this again. Months of year. To insert new abbreviations of month names into the month name array, you could apply the following. Months of year, splice. Five. Still not quite sure what I did. because it's still referring to what I put up in here. Hold up. Okay, let's try this a little bit different. According to W3 schools, we can add. So back in my console, months of the year equals that. What I want to do is months of the year dot splice, starting with where I'm at. So I'm in 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So I want it to start at an integer or index value of 10. I don't want it to take any out. I just wanted to put September, October, November back in. No. What did it take out? Oh, September. Okay. Nope. I'm missing something. What? September, October. Okay. October, November. Oh, it's 14 of them. January, February, March, April, May, June. Okay. Messed up on my months. July, August, June. Well, September, October, November are back in. Obviously, I messed up on my months somewhere, but it's back in. So to add in without taking any out, what you need to do is to start with the index value where you want it to go and take out 0. That's what I should have done up here earlier. Okay. That's that. I'm going to clear this out. That's not what I wanted to do. Shoot! Okay. Okay. Using arrays as data stacks. So arrays can be used to store information in a data structure known as a stack, in which new items are added to the top of the stack or the end of the stack. So it's LIFO or just LIFO, evidently. Last in, first out. Principle in which the last items added to the stack are the first ones removed. You encounter stack data structures when using the undo feature of some software applications, in which the last command you performed is the first command undone. Let's see. JavaScript supports several methods to allow you to work with a stack of array items. For example, the push method appends new items to the end of array. It has a syntax of array.pushValues. Where values is a comma separated list of values to be appended to the end of the array. To remove or unstack the last item, you apply the pop method as follows. So the following set of commands demonstrates how to use the push and pop methods to employ the LIFO principle by adding and then removing items from a data stack. So we got a variable, var x equals an array of A, B, C, x dot push, D, E, and we're going to put a comment there of x equals A, B, C, D, E. Okay. What did I do? So push method appends new items to the end of an array. It has the syntax. Oh, okay. So we had ABC, and then we told it we wanted to add D and E, and it gives us a value of 5. It's telling us now we have 5. So we run X. It tells us these are our values, A, B, C, D, E. That's what that comment was supposed to be. So let's try pop. X dot pop is E, and what that does is removes the last items of the at a time, one at a time. So we did X dot pop, so we removed E. So if we run X, it's just A, B, C, D. We do X dot pop again. It's going to take out D, and we hit X, not alert. X. It's going to be ABC. In this code, the push method adds 2 items to the end of the array. We did push it or you pop it. So a queue, which employs the FIFO, first in, first out principle, in which the first item added to the data list is first removed, is similar to a stack. You see the FIFO principle in action in a line waiting to people to be served. For an array data that should be treated as a queue, you should use the shift method, which is similar to the pop method, except that it removes the first array item and not the last. JavaScript supports the unshift method, which inserts new items at the front of the array. So to reverse an item in array, we use array.reverse, array.sort, to sort them. To sort in any order, use an array.sort with the function name. To extract, we do, to take out items, we do array.slice. To remove items, from an array. To remove items from an array. To extract items and take them out just to be on their own, we do array.slice. To remove items, we do array.splice. So, let's see. Let's play with that a little bit in here. So let's put our D and E back in there. D with the push. E. Okay, so we do X. We now have A, B, C, D, E again. But if we want to let's do the reverse. Our X is our array, our variable name for the array. If we do reverse, it's EDCBA. If we do an array sort, I don't know how that works with this. We'll see. It's okay, A, B, C, D, E, in alpha order. I'm not going to do that one because I don't have a function built in here. Array slice. We're telling it where to start is integer 3, which is D. And let's not do that one because that's kind of far in. Let's do integer 1, and then 3. Yeah. And I messed that up. Oh, what did I do? Oh, haha. X dot slice 1, 3. Okay, then I hit X. So the error I made, I typed out the word array instead of my array name, which was X. So once I did it correctly, X.slice, I took it, all it does is just slices out the pieces of the pie that I'm wanting, so to speak. I want an integer or index value of 1, and that is B, because this is 0, and enter an index value of 3, which is 1, 2, 3, 0, 1, 2, 3, which is, C, okay, wait a minute, 1, it does not include, sorry. So 3 is 0, 1, 2, 3 is D. It did not include D. But I didn't actually affect any of the X array, the variable X, that's an array. But let's say if I try to do that slice again, X dot slice, I want it to be 1 again. And then I want it to extract all the way up to E, but not including E, which is what slice does. So 0, 1, 2, 3, 4. And it extracts BCD, which is starting at 1, 2, 3, and not including 4. And again, if I call the variable X again, all the array items are still there. Now splicing it is where I start taking stuff out. So X dot splice, and the starting value I want, let's just do 1 again, and then 3. So what that should do is take out B and C. Wait a minute. It should take out starting net with 1, 1, 2, but not including 3. So it'll take out B and C. Oh, it does include it. Sorry. It does include it. So then if I run splice again, it's just A and E. Revise is a comment separated list of any values to replace the old. Okay, we didn't do that. But if we want to put BCD back in, what we can do is X dot splice to put the values. That's what I was talking about right here. This right here. So we're going to do splice. We want it to start at the value index value of 1. I'm assuming we'll go with that. And we don't want it to take any out, so we're going to put 0. And then we're going to put the stuff we want put back in, which is B. And we'll put it in capital letters. B, type capital letters, just so you can see the difference. And then D. You're doing that right? I think so. We'll find out. Yeah, I got that right. Okay. So we got A, and then you can see I put the capital BCD in, and that's BCD and E. Okay. We can add items to the end of an array, and again, it's the end of the array. If you want to put it elsewhere, you use splice. If you want to put it at the end, you do push. So X dot push, and say we want to put F, G, H. Okay, and it gives us, we now have 8. If we run X, it'll give us A, B, C, D, E, F, G, H. And you'll see that B, C, D are still uppercase because that's how it is now. You know, compared with what the last assignment we did. To remove the last item in an array, and again, this is the last item. If you want to remove items within, it's not the last item. You use slice and spice, or splice, sorry. X dot pop, when we want to just, I think that's it, just X dot pop. Yeah, and it's H, so we run X again, it's A, B, C, D, F, G. Summarize the 10.7, summarize several other methods can be applied to arrays. Arrays are powerful and useful features of JavaScript language. I'm not going to worry about this. Let's just kind of focus on a few at a time, then you can build it. Okay. So that's the end of that. Remember, you need to do the quick check. There's nothing for you to turn in on that, but you need to do it because we'll be using it later. So it looks like the only assignment you actually need to turn in was just wherever that calendar was, wherever we left off last. I think it was just on 10-2. I believe that's it. So just turn in whatever that calendar is, where it was up to that point, which took me to basically that's where we ended August 2018. And you don't. This is stuff I did to practice it, and we'll go over the stuff in class as well. But this needs to be done. Okay. What was the assignment? Of course. Okay, so this needs to be done. Due Monday, 11:59. Just upload that, the calendar, the files, which were the JS and the August HTML. Okay, that's all for this video.